Dear students, welcome to a new video for the Operation Research course. In the previous video, we already started the transportation model, and we have three methods for starting solution for any transportation model. And we said that the transportation model is a special case for minimization problems for the linear programming model. We interested only to minimizing the cost of transporting the values that we have from the source to destination. So we interested in minimize the cost. So it's a special case for a linear programming model. Now we will start the third method that we will have and study for the methods for starting solution for this transportation model. Already we studied two methods, the least corner method and the least cost method, and solve the same example by using the two methods and find that the least cost method give more better starting solution than the northwest corner method. Now let's take the starting solution by using the Vogel approximation method and then compare between the three methods in the result for the starting solution. Then in the second part in this video, we will take how to get the final solution or optimum solution by using the method of multiplier, depending on either the one of the three methods. No problem what method you start to and then get the final solution and get the optimum solution by using the multiplier method. Now let's start to study the third method that we will studying in this part for the starting solution, which is the Vogel approximation method. We have the same example with the same values. The values in the corner here is the values for the costs, 10, 2, 20, 11, and so on. These are the cost of transportation from source and to destination. And we have a values for the supply, which is 15, 25, 10, and the demand was 5, 15, 15, and 15. This was the demand and the supply for the example that we have. Now we will start by using Vogel approximation model. Vogel approximation model is the nearest model for the least cost method. That we depend on the least cost, but in the least cost method we choose any one cell that it's at random that have the least cost only. But now we will depend on what's called by a row penalty and column penalty. Row penalty and column penalty. What does this mean? Let's see. The row penalty is the difference in between the smallest two costs in each row, and the column penalty is the difference between the smallest two costs in each column. Let's now get the values. Let's see. Now the row penalty for the first row, which is the difference between the two least values, which are 2 and 10. The difference between 2 and 10 equal to 8. And the row penalty for the second row, the difference between the listed two costs, which are 7, 9, each equal to 2. For the third row, the difference between the least costs, which is 4, and 14, which is equal to 10. Now let's get the values for the column penalty, which is the difference between the least two costs in each column, which are, for the first column, the difference between 4 and 10. which is equal to 6. This is the difference between the least two costs, which is 6. The difference between 2 and 7, which is equal to 5. This is the column penalty for the second column. The column penalty for the third column, which is equal to 16 minus 9, which is equal to 7. And finally, the column penalty for the fourth column, which is equal to the difference between 18 and 11, which is equal to 7. Now, again, in the first step, we have a row penalty and a column penalty for all the rows and all the columns by subtracting them, the least two costs in each row and each column. Now we will use the maximum value for all the row penalty and the column penalty to determine what column or row we will begin with. Again, what is the greatest value for these values 8, 2, 10, 7, 7, 5, and 6? The greatest value, of course, is the number 10. Depending on this greatest value, we will decide to begin with the row number 3. So we will begin this row to be the beginning cell in this row because it have the greatest row penalty or the greatest value from the row penalty and the column penalty. So let's take this row and look at the values of the costs inside this row. We will find 4, 14, 16, and 18. So we will take the smallest cost value to starting in. Now we will move to the smallest cost value in this column, which is 4. So we will begin with cell O. Now we want to determine what cell that we will begin with in our solution. In the northwest corner method, we begin with the cell that in the west corner. In the least cost method, we begin with the cell which has the smallest value. But here in the Vogel approximation method, we decide the cell that we start with depending on the maximum value for the row penalty and the column penalty, like this. After we getting the row penalty and the column penalty, which is the difference in between each least costs in each row and the column, we take the most greatest value and deciding the row or the column that we will start, and in this row and the column we will start by the least value. So as we said before, that we depend on the least value but in another way or different way. So we will start with this cell that have 4 inside it as a cost. Now this cell is an intersection between the demand that is 5 and supply is 10. So we will take the least value, which is 5. Here will be 5 and this will be 0. Subtracting 5 from 10, this will be 5. Now we haven't any more values for this column, so we can't get any row penalty from it. The same steps we will do again for the row penalty to get what cell that will we start with again. Now we will get a row penalty for the second step, which is the difference between the two smallest values. Now it is 2 and 11, so the difference is equal to 9. Then the second row, 7, a difference between the most least values, which are 7 and 9, which is equal to 2. And then the value, the difference between 14 and 16, which is equal to 2. Here was 10, and then this is 2. Here for the column penalty, we will take the difference in between the still 7, and here difference between the least cost is equal to 7. Now this is still 5, but we haven't any difference in between here in the column penalty. Again, we will choose the greatest value to be the entering values or the value that we will start with. So what is the greatest value for the row penalty and the column penalty here? The greatest value is 9. So we will take 9 to decide that is the row or column that we will start with. So we will start with the first row and choose the smallest value in this row to be our starting solution or starting cell. The cell equal to 2, so it's associated with 15, and 15 you will take here 15, and this will be 0, and if take we have here 15, it's equal to 0, but we here equal to 0, we already we haven't any the demand for in this column, so we can't use it anymore. But we can't get it 0 from the row and column at the same time, so we will take only one column to be get it blocked. Not here the row we can't block it and the column at the same time, so we choose either to block the row or column. It's up to you, but we can't block the two at the same time, so we have here 0. Now we will go the same steps again for the row penalty and the column penalty. Please concentrate. If you don't understand in the 2 times that we already say, you maybe understand here. Now we will take the difference in between the 2 values. We have already only 2 values in this here. We get the values 9 and then the difference equal to 11, difference between 20 and 9, and difference here to 2, here 7, and here 7, and here there is no difference, here no difference. So what is the most value in the row penalty and the column penalty? It's 11. So we will start with the column, the row number 2, to get the value. So this column here, we will start. What is the least cost? The least cost is equal to 9, so we will start with this value. The least cost, which is 9, here associated with 15 and 25, so we will take the smallest, which is 15, to be here 0, and 25 will be here 15, 25 subtracting 15 equal to 10. So there any more here values, we can't take any values, and we haven't only 3 cells, and we can't make any more row penalty or column penalty. We depend on the least values in the 3 cells that's left here. The 3 values, we will take the least one or the least cost, which is 11. 11 associated with 0 and 15, so we will take 0, and this, okay, here still 0. 0 minus 15 minus 0 equal to 0. Now we will move to the another least cost, which is 18. So we have 5 and 15. We will take the least one, which is 5, to be 0, and 15 will be 10. Finally, we have this cell, which is associated with 10 and 10. Because it's a balanced model, of course you find it 10 and 10, so it's 0 and 0. Now, if we count up the number of basic cells, we will find 1, 2, 3, 4, 5, 6. The number of basic cells, as we said before, equal to number of columns plus number of rows minus 1, which is equal to 3 plus 4 minus 1 equal to 6. This is our solution is true. And then we will compute the value of that and the starting solution by using the Vogel approximation model by multiplying each value by its cost of transport or the transported cost to get that equal to, here let's erase it, to getting the value for that, which is the starting solution for the Vogel approximation method equal to 15 times 2 plus 0 times 11, 0 times 11 plus 15 times 9, 15 times 9 plus 10 times 20 plus 5 times 4 plus 5 times 18, which is equal to $475. Now, if we recall the three values for the starting solution for a northwest corner method, Vogel approximation method, and the least cost method, we will find that the best starting solution with which is have the minimum cost, because we seek to the minimizing the cost, so the best for us is the minimum cost, is by using the Vogel approximation method, while the northwest corner method is the most easier method for calculating the starting solution. So the Vogel approximation method enable us to get the final solution more faster than any method, because have a direct to the final solution, because it's already minimized the cost in the starting solution. So when we want to get the final solution and optimum solution by using the Vogel approximation method as a starting solution, it will be better than any method for the starting solution. Now we already covered the three methods that used for getting the methods of the starting solution. Please study hard and get more examples for it to benefit from this method. Now let's move to the methods for the multiplier, for that to get the optimum solution. Here there are a summarization for the three methods in the following tables. This is the first method, northwest corner starting solution, and the basic cells, number of basic cells is equal to 6 that have the values inside it. And the second is the least cost starting solution. We began with this cell because the least cost here is equal to 2, and then we move to the cell for the least one, and then 9 and 11, 18, and ending with this cell. And this is by using the least cost starting solution. Then we take the Vogel approximation method and getting the Vogel approximation method as a starting solution, and getting the row penalty and the column penalty for each row and column, and getting the values for the starting solutions that we getted before. Here are three examples for the transportation models. You can practice more on them and getting the starting solution by any of the three methods that we have, or for more practice for every problem, try to get the starting solution with the three methods and comparing between the three methods. You will find that the Vogel approximation is the minimum cost, but is more steps, and you will find that for in the most cases the northwest corner is having the more starting solution value, but it's easier than the northwest, easier than the least cost and the Vogel approximation. Please practice more and more, and in the next video we will take how to get the final solution by using the method of multiplier. Thank you for this.